Now we are going back to the uh, cylinders and quadric surface. So last time I mentioned that um, the all the surface that consists of lines that are parallel to the given line and pass through the given plane curve, they are going to be defined as cylinders. So this is a cylinders examples, parabolic cylinders. This is another cylinders as well, and there are uh, another equation that is we say the general equations that we can write the equations as. So we can write incomplete all the terms coefficient in x, y, z. This is all the combination that we have. Okay? So this is the general equations. So a quadratic surface, this is the second degree equations in x, y, z, and how we write the general equations is this. And if we could translate and we can rotate the these equations, the most standard forms or the most probable case for the equations. So standard forms only two equations. There is ax squared plus by squared plus cz squared plus a constant equals 0, or equals 0. Now, of course, this should be understood by, it could be, for example, it could be understood that, for example, for the second one, if we have the quadratic in x and y, and the linear is on z, but we could have many variations and combinations. For example, we have x squared and z squared, and then this is y, or we could have y squared, z squared, and this is x. Okay, we can have that also in terms of the forms. Now, we're going to see from these standards, we can have many variations. And the important thing is we could know how to draw and how to visualize this graph in terms of the in visuals. Okay, so we are going to be list every standard forms in this quadratic surfaces. So let's start with some examples. Okay, so the first example is trace this x squared plus y squared over 9 plus z squared over 4 equal 1. Now, of course, we can start by first is taking, let's say z equals 0. Okay. If z equals 0, then we have an ellipse, right? This is an ellipse. And if we take z equal a constant, now we can write this as a k squared over 4, right? So k squared over 4, which is another constant. Then this is actually the ellipse that is going to be provide that k squared need to be less than 4. Okay, so that it will be an ellipse. So this ellipse could have different length in the major axis and the minor axis. If you remember the ellipses, if you have learned ellipse before, then this is the ellipse. We call this the major axis, and this is the minor axis. Okay. Now, to see this, take it through that if we draw in terms of, let's say, so if this z, this is x, and this is y, then at z equals 0, which means at this plane z equals 0, which means in the origin here, then we have x and y. X is having the major axis length 1, and y will be 3, maybe around here. Maybe let me make it more clear, maybe that. So that's the ellipse. And of course, the k should be equal with 4. Then we have here is also, this is 2, this is 1, this is 3. How we get 2, that is actually we can also see from here. So we could also make another ellipse if you want. Okay, you can check. For example, if we take y equals 0, so we have this ellipse. Okay, so we have this ellipse as well, which is going to be this. Okay, and another ellipse that could be possible is when x is 0, which gives you 3 and 2. So we have that. Okay. Okay, maybe it's not really good and proportional, but you can see that we have 3 ellipses for each when x equals 0, y equals 0, and z equals 0. So we can have these three ellipses. So this is the first ellipse, second ellipse, and the third ellipse. Okay. Now, of course, if you see the example here, we have some constant k that is going to be depends on if you see this. Okay, let me just write here. So whenever we have k in between, it means that it will be having this many ellipses. That's for k between -2 to 2. Okay, because if we have k equal 2 or -2, it is perfectly at this point here, the 0. So we don't want that to be our ellipse because it's a point, not an ellipse. So this is what we call as a ellipsoid. Okay, we say this is an ellipsoid, and if the all the constant in the ellipse and they are equal, we'll have the sphere. Okay, so if we have this is sphere with radius. Okay. Okay, first ellipsoid. Let me write. Done. Then the second example. Let's go. We have z equal 4x squared plus y squared. Now this very similar to what we have in ellipsoid. We could make one of these variables 0. So first maybe taking x equals 0. So we have z equal y squared, which is a parabola, right? So we could, let's say we have the drawing here. So z and y, so we have maybe, so let's say that is our parabola. Then we could take, um, let's say, if we take the x as a constant, and we could see that we can have a difference in the parabola. So we could make the parabola um, going up or going down. So we can see it's going to be, uh, if we slice the graph with any plane that is parallel to the YZ plane, we are going to see the uh, we're going to see like this. Okay, so if you can imagine that, maybe not really good, not really clear. But if we slice, then we can slice and make another parabola. And similarly, if we take y equals 0, we have another parabola for x squared. So we have, let's say this is going to be uh, another direction here. Okay, and then if we take z equal 0, or maybe z equal constant, at certain point, this can be understood as an ellipse. So we can take this. So if k is 4, then this will be an ellipse. Okay. So let's say we have 4 here. Let's say this is 4. So when this 4, then we have an ellipse here. I think should be describe all the. Okay, that's an ellipse. So this is an ellipse. So since this is an ellipse, and this is parabola, this is also the other one, also parabola. We call this is a elliptic paraboloid, which is having an ellipse as in one top surface, and then the other uh, part of the surface will be the parabola. Okay, so yeah, basically that is our elliptic parabola. Or clearly we could see here, maybe it's more descriptive. Okay, so if we slice, for example, if we slice through here, we could see that it can be like that, right? So we could slice it everywhere. So that's how we understood the k, okay, the k here. Okay. Same thing with this. If we take y is equal k, so yeah, I think the next one will be a little bit quite complicated. It is, we call um, the combination of hyperbola, parabola. Okay, but we have two hyperbola, two parabolas. So let's start by taking each one of them, taking as 0, so we can have or as a constant if you would like. So we could take, let's say, start from z equal constant. So we have this, and if k is 1, then it will be hyperbola. we could understand from here. And when x equal k, this will be a parabola. And when y equal k, this will be another parabola. But of course, because it's negative x squared, the parabola will be like this will be like that, right? So we have here the upwards parabola, okay, with different constant. And this is also another parabola. This is the downwards parabola for the negative x squared plus k squared. And we could understand the k depends on, well here we could understood for some point of variables, 0, 1, 2, okay, both are negative and positive. And then the last part will be the hyperbola. Now you see that the hyperbola, we have two different hyperbola, right? We can have hyperbola that is going like that, and we have hyperbola that is going to be like that. But here it seems that they are going to be in one plane. But actually, if you see from this part here, the hyperbola can be understood as, if k is positive, this is the first hyperbola. The second hyperbola, let me check here. The second hyperbola, we could write this as x squared minus y squared equal if we have a negative k, right? This is another way we say if we have a k is negative. Let's say this is still k, but we can take notes that this is k is positive, this is k is negative. Well, anyway, we can have two hyperbola. So we could have hyperbola that is going to be this way, and hyperbola that is going to be that way. And of course, this is going to be traces by depends on each plane, okay, each plane. And we are going to combine everything here. We're going to combine this parabola, that parabola, and this hyperbola. So imagine that we are going to, let me write with the yellow color here. We're going to have that parabola, okay? And then we have, here is the hyperbola and parabola, parabola here. Let's say we have that. And in between this, we could have another hyperbola here. So maybe it's too messy if you could see that, but I hope you could get the idea, so that we can write here that this is actually the possible forms. So we could have this part, okay, and also this is the part, okay, and this will be the hyperbola. Okay. So this is this is hyperbola and parabola. Hyperbolic paraboloid. And you could see that we could imagine this as a saddle. And this is what we call at the middle point here. This is we call the saddle point. Will be important in later discussions. Okay. So that's how we get the surface. One of the thing quite a complicated surface is this hyperbolic parabolic. Okay, and then another example is this, and we could start with a, a very similar structure or steps with the previous one. So we could start taking, let's say, taking y equals 0, and then maybe taking the x equals 0, which gives you the both are hyperbola, right? But if we take z, we could get the ellipse. So it's going to be, one of them is the ellipse, and two of them will be the hyperbola. So with x, let's say x is, so z, x, y. So I think before you uh, getting to know more about the quadric surfaces, I think it's better for you to review a little bit about the conic sections. This is supposed to be in chapter 10. I skip it because I assume that everyone has a quite familiar to this conic section. But if you haven't, I think you can review the conic sections. Okay, so conic section we learn about a parabola, hyperbola, or ellipse at the beginning. Okay, at least these three. Okay. Okay. Now we draw the x and z. The x and z. So for x and z, we have the um, we have that, right? Hyperbola. And then for y and z, we have that. Okay. And then we have x squared over 4 plus y squared. That is going to be our ellipse. So we can take this. This is 1, and this will be 2. This is going to be 2. Okay. Suppose this is 1. Okay. And will be another ellipse. This is another ellipse. So it's like a face, not face, face for putting flowers, right? So this is we call the hyperboloid of one sheet. This is the figure. Okay. Okay. So yeah, I hope all the procedures make sense, and every time you have, maybe you have been given this equation like the surface, you could trace out by yourself, or checking through check the GeoGebra. It can also generate the surface easily using the 3D system. And yeah, but what I expect is the logic, the reasons, and um, all the processes. Okay. Okay. Lastly, is this surface. So first we can take, like usual, we can take the, let's say 0. So we have negative, so 4x squared minus y squared equal negative 4. Right? So this will be x squared, and I will make it into positive and divide by 4. So we have another hyperbola, right? This is hyperbola for y squared minus x squared. And then taking the x equals 0, we have 2z squared minus y squared equal negative over 4. Same way, we could take the divide by 4. Okay, this is another hyperbolas. And of course, the last one, if we take the y equals 0, this will be now look at this equation. This is quite interesting. So this will be an ellipse, but it's not an ellipse. So this will be negative x squared negative c squared over 2 equal 1. So this will be the negative counterpart of the ellipse. So we could understood there will be an ellipse if we take the y as a constant. Let's say it could be understood as this. So 4x squared plus 2z squared equal k squared minus 4. Okay, and we need to make sure that k squared minus 4 is less than, or this is at least this is going to be equaling, or k squared should be less than 4, or not less than 4, supposed to be greater than 4. It should be positive, right? It should be positive. At least k squared is 5, right? At least, or this absolute value is greater than 2. So we could write as okay. So we can also written this this ellipsis into x squared. We define with the k squared over 4 minus 1. Okay. Now this traces, we could see that when we have the x, y, z, if we start to making the hyperbola, we could start from the yz and xy. So for xy, I think we have y positive, right? We have y positive, so we should have this and that. And then for y and z, we have supposed to be this way and that way. But I think my drawing not really clear. It's supposed to be, this one should be going to be cleaned. Okay. And we are going to have the ellipse here at the end. Maybe it's supposed to be like that. Okay. Okay. Supposed to be like, so it's like a bowl at the both ends at the point. And this two, this point, this is y equal 2, this is negative 2. So this is negative 2. This is y equal 2. This is based on the k that we define here. So the k at least need to be greater than 2, right? Because at the middle part, there is no surfaces that can be defined because of this k. Okay? Now this 2 bowl, we call this the hyperboloid of 2 sheath. Okay, so this is how it looks like. Okay, so it's actually, this is the hyperbola. Okay, another hyperbola is this. Okay, so that's it, all the quadric surfaces, and I hope we can see that all the terms here we can so I expect you know how to trace. So every time we have a surface that can be visualized, if you can visualize like through some picture, I think it's better to see the picture that usually we are going to have in the chapter 14. Okay, we have many surfaces, and also chapter 15 that sometimes we need to imagine the visuals, but it's not always. But it's better if you can um, and understand the traces in the surfaces. Okay, so we have this 6, and hopefully this can be helpful for your study. Okay, especially for multivariable calculus, starting with chapter 14. Okay.